Oh, well, I was going to bring my iPad. At least it's not. At least it's just paper. Well, I wanted first of all to say that when I received Ben's book, I was deeply impressed by it, not just as an illustration of how ideas in complexity can be applied in a detailed way to a real world problem, and a very important real world problem, but also just as a general introduction to the notion of what complexity means in thinking about our social systems. I think he does a fantastic job of explaining that, and has just done so again. And I just want to expand a little bit on why I think it is that thinking about social systems in general as complex systems has both validity and value. And I want to touch a little bit on the challenges that this perspective poses, which, thank you, that's very wise, which Ben has already touched on. No one needs persuading that our societies and cultures are complicated. What I want to emphasize is that asserting that they can be considered complex systems, says something rather different. And perhaps surprisingly, this assertion implies that they are, in some ways at least, perhaps less complicated than might be imagined. That complexity actually tends to produce, or can produce, degrees of organization that something that is merely complicated doesn't necessarily have. Now, there's a long tradition of claims that social science can never be really made into a science because human beings are just too complicated, too unpredictable, and too irrational to be described by behavioral rules. But as Ben pointed out, there's also a long tradition which assumes that social science is only the last bastion in a gradual conquest of the physical world by the approaches of Newtonian physics, and that it will, in the end, turn out to be just as rule-bound as the motions of the planets. Economists since Adam Smith have often succumbed to that view, sometimes to the extent of insisting that their theories must respect that view, regardless of whether the real world does or not. And in fact, I was really struck by how pretty much everything that Ben said in his talk, you could simply replace aid by economics, and you have the same story. And I think that includes the fact that conventional thinking in economics sometimes works very well. And the challenge is to find out when it does and when it doesn't, and why that is. And in my view, the complex systems approach to social science seeks a middle ground between those things. It recognizes that there's already compelling evidence of regularities and patterns in human behavior, particularly when considered en masse. And it anticipates that more of these will emerge, but it also needs to confront the limitations of such rule-based behaviour, and needs to accept that there are some areas of social behaviour that this view is sure not to fit very well at all. But what I think has been insufficiently explored so far is the question of what happens when is meets ought. It's fashionable these days, and I think it's long overdue, to point out that Adam Smith was, in the end, a moral philosopher, and that he never lost sight of, in his account of how the economy works, of the fact that we must reach some accommodation between how things appear to happen and what we would like the outcomes to be. And in considering that tension, I know of no nicer example to sort of illustrate where we can go with this than one that's now an old and very simple model. It was described over a decade ago to try to understand how pedestrians move around space. And in fact, this was a computer model specifically designed to understand how people move around grassy spaces. And the reason why that was significant is that it allows people to leave trails of where they have walked. They wear the grass away. And then we have the potential for people to interact with each other. There's a feedback, there's an interaction there, which is at the root of all complex behaviours. And in particular, there then arises a conflicting tendency to either walk along routes that take us most directly from our point of entrance to our point of exit, and a tendency to walk where we see other people have already walked, either because we think that must be the way to go, or because it's just easier, because the grass is worn down, or whatever. And researchers at Stuttgart set up a computer model of this process, which reflected these tendencies, and they looked at how the trails of the walkers evolved over time. So they initially had the walkers in this model walking over this grassy space. It's red grass here, I'm not quite sure why, and they're coming in and coming out from the four corners of this space. Now, initially, what they found was that the trails that were worn down were the ones that just took the most geometrically straightforward routes between these different points of exit and entrance. But over time, these mutated into something else. They took on a less geometric and more organic appearance that, in fact, didn't offer the most direct routes between any of these entry and exit points at all. And those patterns did look rather similar to the ones that we can find in the real world. Here's an example from the University of Stuttgart, in fact, of a pattern like this that's just self-organized. Park planners know very well that these desire paths develop in parks, and wouldn't it be nice if we were able to predict them and therefore to construct them that way in the first place? Now, this is a trivial example, really, and in fact I was delighted that Ben mentioned what have the Romans done for us, because I always remember 10 years ago, I guess it was, I was on the Today programme. I found myself unwittingly debating what these complexity approaches might do for social sciences with a social scientist who was highly sceptical of the whole idea. And I began in the same way by talking about, in that case, traffic, which can be modelled in a very similar way, and saying, you know, this is just a simple example of how it can happen. And his response, he was channeling John Cleese, I think, his response could be paraphrased as, well, yes, of course, the roads, but apart from the roads, what has complexity ever done for us? And but that is, I think that is a question that we do have to ask. You know, how far can we take it beyond these simple systems? But the real value, I think, as I say, is the metaphor afforded here, because first of all, this example shows that non-intuitive behavior that one couldn't have predicted in advance does seem to be amenable to modeling based only on some very simple assumptions about how people behave. And secondly, this kind of complexity-based approach can grow realistic-looking solutions from the bottom up, just by assuming some simple behavioral ground rules. And third, there's potential value in figuring out how people are naturally disposed and how they collectively seem to organize themselves, rather than trying to impose some preconceived plan that they might well undermine anyway. And I might add that pedestrian and crowd models of this sort are only one small part of a broader move to regard cities and urban environments as complex systems. And I suspect that this will be one of the most important areas in which this complex system approach will start to pay dividends in the near future. I'm very glad that Ben alluded to the work of Jane Jacobs, who was really the first person to totally grasp this perspective as it applies to urban development. The majority of people now, and this is a recent thing, now live in cities, the majority of people in the world, and they're clearly going to keep on growing in the foreseeable future. And yet we've still only a rudimentary understanding, sometimes disastrously so, of how cities function and develop and grow. And what's more, this understanding has tended to evolve along quite distinct channels with little interaction between them, so that, for example, transportation networks are considered in isolation from patterns of wealth and other demographic changes, or changing modes of energy supply and distribution, or problems associated with migration and climate change, or planning for disasters. And we can't afford to do that anymore, to have that separation. And, you know, if you needed an obvious example, New Orleans several years ago reminded us of why we need to integrate all of those different considerations into the way we think about cities. And there are some people who are now really starting to recognize this and to build on it, and prominent amongst them are the folks at CASA at UCL, and I know that there are some people here from that group, and I want to mention in particular these recent publications by Mike Batty at that group, which make an eloquent case for why cities can and must be considered as complex systems. Now, Ben has explained why some problems in healthcare, such as the AIDS epidemic, also need to integrate a variety of different perspectives into a complex systems view. And I would go so far as to say that some of the most serious challenges in healthcare in the coming years are going to demand better understanding of social interactions and networks, just as much as they are going to need better drugs and other medical interventions. Contagious disease is certainly one area in which it matters who we're coming into contact with and how we're moving around our environment. But there's also, I think, good reason to broaden the view of what contagion means, to include the psychological influence of the networks, the social networks of friends and peers that we belong to. It's been found, for example, that smoking behavior is influenced as much by who we know as much as it is by top-down campaigns of public information and taxation of tobacco and so on. Here, for example, there are two small parts of real social networks that connect people who smoke or who don't. So one is from 1971 and one is from 2000. And here the large yellow spheres denote the smokers. And so you can sort of see straight away that one good message is that smoking is declining. But it also shows you can't immediately see this by glancing at it, but you can see it by analysis, that the smokers that remain form small clusters that reinforce each other and that also tend to appear towards the periphery of these networks. They're the ones that are hard to reach, that are hard to get through to. What's more, this sort of social contagion, which of course can spread good as well as detrimental behaviors, this is also found, has also been found in levels of obesity. People who are more likely to become obese if their friends and peers do. And it is clear that that's not just they happen to know people who are also obese. It's the process of becoming seems to be influenced very strongly by what the peers are doing. And this suggests that tackling these health problems can be more effective if we understand how behaviors like this propagate on these networks. And there are emerging reasons to believe that antisocial activities such as crime share similar attributes. And I could go on talking, for example, about how approaches like this, bottom-up modelling and thinking about complex systems, are also being used to try to understand the causes of things like political extremism, terrorism, war, and economic crises. There are good reasons in all those cases to hope that something of real value will be achieved, but there's also an evident danger of implying that all of the world's ills are somehow going to be vanquished by this kind of thinking. The fact is we simply don't know yet how useful it will be in identifying new and more effective solutions. The technical questions about this sort of approach are well recognized, at least in principle. For example, how do you evaluate the uniqueness of your model? How can you test your model against real data? How far can models be predictive rather than just descriptive, and so on? Some of the harder questions are ones that Ben has already mentioned, but I think bear reiterating. And here, the key issue is this tension that I mentioned between ought and is. Probably no one is going to question the value of having models that allow us to design better, more amenable, safer public spaces and highways. No one's going to complain about approaches that can alleviate crime and war. But I think that one of the big challenges is going to be to avoid this complex systems picture becoming just another prescription for justifying preconceived top-down goals, much as conventional economic theory has sometimes been commandeered to support particular regulatory regimes, or rather lack of them. And even setting aside the question of who decides what the goals are, there's a big question of whether bottom-up descriptions of social behavior can ever become reliable enough to enable the system to be engineered in some way by tweaking the ground rules towards a particular outcome that we might have decided is a desirable one. Can we do that? Perhaps what's really needed to enable any aspiration like this is just a change in thinking. One of the great advantages of complex systems, for example, is that they are adaptive. When new circumstances arise, new and hopefully better adapted behaviours can result. And their problem-solving methods can be iterative. You don't necessarily get things right on the first attempt, but using this sort of approach, you can learn from mistakes. But that's only possible when mistakes can be seen as opportunities for learning and not as policy failures. And I don't think we have yet a political or an institutional culture that permits that way of thinking. And I suspect that's what we're going to need if we're going to exploit complexity thinking to its full potential. Thank you.